Hi everyone, my name is Edmund Lin, and today I'm presenting my capstone project, the Propertly Chatbot, which is essentially a predictive virtual assistant to help predict the price of your property properly. All right, without further ado, let's dive into the first burning question, which is why? Why did I choose this project? What's the purpose of me making this product? Or how is this product helpful or maybe even impactful? Well, first thing to understand is that the word to describe Malaysia's property market is full of uncertainties. It's very unpredictable, especially after the COVID-19 global pandemic. The situation is like adding oil to fire. So even in this kind of uncertainty, in these times of unpredictability, stakeholders still need to make decisions, such as if I am a property developer and I want to build bungalows to sell, what will be a good price to sell? Or if I am a property investor and I want to buy properties to be rented out or to do Airbnb, what will be a good entry point to buy a house? Or if I am a student and I am a student and I want to find a place near my university to stay, what will be a good price to rent? These are all very, very good questions, but without a good answer. The nearest alternative to solving these problems would be going to property websites like iProperty or Property Guru or Property Queen and just select maybe 20 to 30 properties that's similar to what I'm looking for and just maybe take the average of these properties and be like, okay, maybe the average of these 30 properties will be the price I'm looking for. But this is a very non-efficient and non-data driven way to solve the problem. My goal today is to provide a solution to help the stakeholders mentioned above to make informed decisions when it comes to matters concerning property pricings. So let's dive into my project roadmap where I'll bring you through each single thing listed here, such as scraping the data, cleaning the data, analyzing the data, then we train the model, and then we deploy the model. So the first thing first, scraping the data. As you all know, just like cooking, before you cook, you need to prepare the ingredients. You need to get the ingredients. Just like a data science project, you need to gather the data first. So what I did was I went to the iProperty website and I used a tool called Octoparse to scrape two data sets, one being the sale data set and one being the rent data set. As you can see on the screen here, there's a total of 24,000 rows of data. This right here is a demonstration of me using the tool to scrape the data. And after scraping the data, I proceeded to clean the data, such as dropping the empty values and dropping the duplicated values. I converted the string to numeric values using regex, and I also extracted some further details, further information from the existing columns. These are the technical parts. Let's look at the results. So first of all, we have the sale data set. As you can see here, there's 11 columns of data, and the price is a 6 to 7 digit figure, which makes sense. Then we have the rent data set, which also has 11 columns of data, and the price being a 4 to 5 digit number. So after having these two clean and ready to be trained data, let's first analyze the data. First up, we have the correlation heat map, whereby you can see that the bedroom and bathroom has a high correlation of 0.83. So this is not surprising, as we all know, when there is more bedroom in the house, there's more people living in the house, you should have more bathroom as well, or else the bathroom queue would be very, very long. Just imagine 10 bedrooms and one bathroom. That's kind of wrong. But what kind of surprised me was that the correlation between a bathroom and price is higher than the correlation between the bedroom and price. My takeaway would be the number of bathrooms will affect the selling price and renting price more than the number of bedrooms. So this is quite a valuable insight. Next here, we have the comparison between the price and state. So as expected, Kuala Lumpur, Selangor, Putrajaya, and Penang each has the highest selling price and the renting price, as you can see on the screen right here. And contrary to that, what we could see is that states like Kelantan, Labuan, and Perlis, each of them has like the lowest selling price and also very little listings on the iProperty website. In fact, Labuan and Perlis is completely absent in the rent data set. So these are some of the most inactive states in the property market. Next, what we have here is the price versus property type comparison, like the price comparing with the condos and bungalows. As you can see, bungalows and condominiums sell for the highest price and also at any price. Next, here we have the price versus bedroom comparison, and also we have the price versus bathroom comparison, and also the price versus car park comparison. And after analyzing this data, we proceed to training the model. At the beginning, I have 8 models in the mind, but 2 of them doesn't work, which I stated it out here because the metrics that it returned is completely off the charts and is not interpretable. But with the remaining 6 models, I've trained it on the sale data set, and as you can see here, 5 of the models perform quite well, with XGBoost coming in number 1, and then we have neural network, which is performing quite well as well, 0.78 and 0.79 in the R2 score. And for the MAPE score, we could see that the scores are around 0.3 and below, and random forest is coming in number 1 for the sales data set. And as for the rent data set, the results are quite coherent. We could see that 5 of the models perform quite well, with support vector machine performing quite bad. And XGBoost and random forest is performing the best in R2 score. For MAPE score, we can see that random forest and XGBoost has the lowest MAPE score, which is quite good as well. In the end, I selected XGBoost regressor as the model I'm going to deploy because of 3 reasons. First is the R2 score is quite high. As you can see, after tuning the hyperparameters, the R2 score is 0.7 and 0.8. And the MAP, number 2 is the MAP score being quite low. As you can see, it's 0.23 and 0.26, which is in the acceptable range. And number 3, which has the edge over the other models, is the processing time. XGBoost regressor has the fastest processing time compared to the other models. And since we have a winner already, let's deploy our winner. So right now, I would like the audience, you all, to kindly whip up your phone to prepare to scan the QR codes later. So first of all, what I have here for your audience is a Streamlit app. So you all could scan the QR code on this screen here, or I'll be sending the link to the chat, and it will bring you to this interface here. I'll just briefly explain this interface. First off, we have a single model trainer, whereby you could select any kind of regressor you like, such as decision tree regressor, random forest regressor, or even XGBoost regressor. Then you could tune the hyperparameters, and then it will return you with the R2 score, with the MAPE score, with the metrics of the model. The second selection would be a multi-models selection, whereby you could select a few models at the same time, and then you could select the scores you want to see. In the end, it will return you with bar charts comparing the performance between the models. All right. But guys, this is just the appetizer. The main course is coming up in the next slide right here. So now I would like you all to kindly use your phone to scan the QR code on the screen again. And this will finally link you to the product that I've prepared for you all, which is the Propertly Chatbot made with Dialogflow. So once you've scanned the QR code on the screen here, or I'll be sending the link to the chat, it will bring you to an interface like here, a Telegram app. So once you have been brought to this interface, I would like you all to just kindly say a hi to the bot, and the bot will start giving you questions. And for the questions, just follow along and answer. You could answer with normal sentence as well. And then in the end, when it's asking for a confirmation, just say yes, and it will return you with a predicted selling price, or predicted rent price. So right here, I'll just demonstrate once for you all as well. So I'll be changing my screen first to this Telegram app. All right, as you all can see. So let's start with a hi. Lovely day. I want to buy a house. Okay, which state is the property located in? It's in Penang. It's in Bayan Lepas. I want a condo. Okay. It is that's not really any descriptions. Okay, how many bedrooms does it has? It has 3. There's 2 bathrooms. Also two. Okay, correct. Penang, Minor Pass, Condo 322. Yes, it's correct. So my property could be bought or sold at 700K, nearing 800K, which makes sense. It's quite standard specs. And next, we could also try with rent price. So I want to rent a house. Okay, it's near my school, Petaling Jaya. Sorry, it's in Selangor first. Yeah, it's in Petaling Jaya. What type of property is it? It's a terrace, and nope, not really any special descriptions. I just want one bedroom, want one bathroom, and I don't need a car park. Yes, Selangor Penang Jaya, that's correct. Give it a yes. All right, it could be rented at 1,300, which is quite correct. That's one of the price I was offered actually. So with that, you can see the demonstration of it already. Now let's get back to the slides. So coming back here, I would just like to conclude it with the benefits first. So as y'all could see, the product is actually quite useful for developers, investors, and frequent movers. They could check out the price for any kind of spec they have in their mind for a house, and they could use this to set a price for their properties developed. They could see if the price is acceptable to buy a house, to rent a house. All right, but for the future works, I would like to elaborate a bit more. First of all, the data volumes could definitely be increased. As you all could see, I'm just working with around 10K of data for a single model. What would be nice would be if there's like maybe 100K of data or 1 million data rows. And maybe using big data or real-time data, so it will always be updated. But for the second point, which I have highlighted in red, is a more key point where the data feature should definitely be increased. I've consulted with some developers and they said that the actual factors affecting a house is actually more on the external factors, such as where is the nearest bus stop, where is the nearest school, how many office buildings, how many commercial centers are around that area. Those will determine the price of a house, such as like, why Kuala Lumpur and Selangor has a higher price compared to Perlis and Kelantan. That's the reason. But due to resources constraint, I haven't had the method to get my hands on those kinds of data. So that's the limitations I'm facing. But if in the future I could determine like maybe how many shopping malls are in the given postcode, or how many schools are in the area, or what is the nearest highway exit, maybe that could help to better train the model and also show the correlation between the price and external factors. So that would be some considerations for the future works. And with that, I conclude my presentation. Thank you for your time.